Hello, my amazing Algebra 1 students. This is Mrs. A, and I love math. And today we're on lesson 104. We're talking about abstract rational equations. And this one is a rational equation. What they're using this one to talk about, this one would be solved by x. This is not abstract. This is just a rational equation. But what they're trying to point out to you is that the denominator can never be zero. Whether you have abstract or whether you have just regular rational equations, the denominator cannot be zero because we cannot divide by zero. Division by zero is undefined. So, therefore, we know that here x could never be zero, because if x was zero, I would be dividing by zero here and here, which would make the whole equation undefined. Also, x cannot be 2 because 2 minus 2 is 0, and I can't divide by 0. So I have an understanding when I look at that problem that x cannot be 0 and x cannot be 2, because either one of those would make the equation just kind of blow up and be undefined. Now we're going to start working with the abstract rational equations, and you're going to see the same principle. You'll see them say that two things can't be zero. You know, why did they do that? Well, this is the reason that they did it. Okay, so here is example 1, and these are abstract equations because we have a whole bunch of things that aren't numbers, and we don't ever solve this for a specific number. We're going to have variables in our solution, which can be a little bit disconcerting, but just remember that these are special type of abstract equations, okay? So now notice that as part of the problem, they give me x and m cannot be 0. Well, you can see why. X is in the denominator, therefore x cannot be 0. M is in the denominator, therefore m cannot be 0. But once we recognize that, we're going to solve these exactly the way we did the last section with the rational equations, because they are rational equations. They're just not as easily, they're a little bit more abstract. They're not concrete like the ones where we got x is 2 or x is negative 24/13, okay? Here we're going to get x is b plus c over 5 or something like that, where we're not going to have nice numbers that come out. Okay, but we're going to use the same method. We're going to multiply by the least common denominator. So we're going to multiply by, in this case, we must have an x and we must have an m. So x times m. There's nothing underneath the c, so we don't have to worry about it. That's just a 1. Okay, so we're going to multiply the entire equation all the way across by xm. And we could write xm over 1. So when we multiply all the way across, we multiply each and every term. Xm over x, the x's will cancel. M times 1 is m. Xm over m, the m's will cancel. X times b is xb. And then xm times c is just xmc. Now, when we are solving abstract, we have to pay particular attention to that we're supposed to solve for, because you can see I have an m, I have an x, I have a b, I have a c. I have 4 different variables in this equation. This could be very confusing, but they tell me which one to solve for. So I'm trying to get all the m's on one side. I have an m over here and an m over here. I'm going to get all the m's on one side. So let's just go ahead, minus m over here. So this is going to cancel, and I've got all my m's over here, so you're going to see how cool that is. I've got xb equals, now on this side I've got xmc minus m. I'm going to pull an m out to the front, and I'm going to factor an m out. If I divide this by m, I get xc. If I divide this by m, I just get a minus 1. So now to solve for m, I just divide both sides by this factor that is with it. So I'm going to divide by xc minus 1 and divide over here by xc minus 1. Still dividing both sides by the same non-zero constant. Okay, it's a variable here, but it's still not supposed to be 0. So now we're going to end up with m equals xb over xc minus 1. Okay, xb over xc minus 1 is m. So this is my answer. I just ran out of room. M is xb over xc minus 1. So let me hold that so you can see all of those steps. And that is the correct answer. Kind of confusing, but it can be a lot of fun after you get used to it. Now, before I erase this, when you see your book, you're going to say, yep, that's the answer. But notice what they put. They also put, well, because xc minus 1 winds up in the denominator, xc minus 1 cannot be 0. So they make a little addition over there. And they clarify that the denominator that I got cannot be 0. All right, so here we have a over b plus c over d equals x, and we're supposed to find b. We're glad they tell us because we certainly can't find everything, and we're going to find b in terms of all the other variables. So notice that b is in the denominator and d is in the denominator. So they start out with bd cannot be 0 because we know we can't divide by 0. And when we finish, we will put our new denominator cannot be 0 so that we are continuing what they started here. Okay, so we're going to start with a least common denominator. Since the x has only a 1 underneath it, our common denominator is b times d, or bd. So my least common denominator is bd, b times d. So now I'm going to multiply the entire thing by bd over 1. So now here we go. bda over b, the b's are going to cancel and we'll be left with dA or AD. It really doesn't matter. And the b is gone, so there's no denominator, plus BD times C over D. The D's will cancel, leaving me with a B times a C or BC equals X times BD or XBD. So now we look and say, okay, we're talking about B. That's the one we want to solve for. So our method is to put all B's on one side. This term has a B and this term has a B. So we're going to leave this on one side. We're going to get both of these on the other side. So we're going to minus a BC. And over here, we're going to minus a BC. This goes away. So we end up with DA equals XBD minus BC. Now, since I have a B here and a B here, I'm going to pull the B out to the front. B times XD minus B times C. Can you see how I just divided this term by the B and put it there? This term by the B and put it there equals DA. Now I'm trying to solve for the B. So I'm going to divide by XD minus C. So I'm going to divide this side by XD minus C. And I'm going to divide this side by XD minus C. And that cancels, and I get B equals DA over XD minus C. So B equals DA over XD minus C. Okay, now that is the answer, but now we're going to make that little provision. XD minus C does not equal 0. That's our little restriction. It can't be 0 because we're dividing by it. Now, I'm going to say a little side note here. Abstract equations are generally harder. Number one, you can't check them very easily like you could the other rational equations that we just did in lesson 103. I don't want you to get to this more abstract lesson and then all of a sudden go, man, I can't do algebra, because you can. This is a more difficult topic. I want you to try to do it, work hard at it, but you know, it's just a little bit tougher subject. And you're going to find that it is one section out of 120 algebra sections. Don't let it blow your fuse. Okay? So do your best. Try to understand it. I'm trying to explain it, but it's abstract. It's not as concrete. And we have found that as you age, as you get older, your mind is able to understand the abstract better. Okay, so let me show you this one. And if you are doing this math as a middle school student instead of as a high school student, you may find this section is just tough. And that's okay, because as our brains mature, we understand abstract concepts easier. So I want you to work hard, but don't blow a fuse over abstract rational equations. It's going to be something you're going to see again in Algebra 2. It is not something that you have to learn right now, or you're never ever going to get it. You're going to get it again next year in the next class. So just do your best and don't get all upset if you don't get it this first time. Okay? So let's have some fun with this. We understand now that because b is in the denominator and x is in the denominator, that neither b nor x can equal 0. We're going to apply the same method, which is multiplying by the least common denominator. The c just has a 1 underneath it, so our least common denominator is bx. So I'm going to multiply everything by bx over 1, all the way across both sides. So, I mean, you can put it over here too to show you're multiplying it all the way across, but whatever, okay? As long as you do it, the notation's not that important. So b over b will cancel, and we're going to have xa minus bx times c equals x over x. That's going to be a 1bd. Okay, so it's a little simpler because it has no denominator. So now we're solving for x. So we want to get all x on the same side of the equal sign, and they are already, so we don't have to do anything with that. So now we're going to factor out the x. Always factor out whatever you're trying to solve for. So xa, we'll just leave an a, and negative bxc, when we pull out the x, is going to be negative bc. Now you can see that if you distributed this back through, wouldn't you get this one back again? All right, equals bd. We're solving for x, therefore we're going to divide by a minus bc. We're going to divide this side by a minus bc. And this cancels, so x is bd over a minus bc. And that's correct. If you look in your book, that's exactly what they have. And then you're going to say what? A minus bc cannot be 0 because it's your new denominator, and it cannot be 0 because denominators we cannot divide by 0. And there you have it. Okay, so here is the last practice problem. And then we're going to do, the last example. Then we're going to do the practice problem. So what I want to do here is I'm going to, right over here, we're going to make a little step list, okay? So that when you're doing these on your own, you can follow the little step list. So remember that x cannot be 0 and n cannot be 0, so that's why they say that. So we're going to multiply by the LCD. So step 1, multiply by the LCD on both sides of the equation. So here, since this over y is over a 1 and k is over a 1, our least common denominator is just xn, x times n. So we're going to multiply everything by xn over 1 all the way across the entire thing, okay? So multiply by the least common denominator. So let's do that. X and x will cancel, so we'll be left with NA. And there's nothing to cancel, so we're going to get an x in y, but it's going to be negative. And then the n is going to cancel the n, and we'll have an xm equals, there's nothing under the k, so it's going to be an xnk. Okay, so we multiplied, we did step 1. Let me hold it a little bit closer since it's pretty long. Okay, now remember step 2 is to look up here, see what I'm solving for, and get all of the variables that I'm solving for on one side, okay? So let's say step 2, variable solving for on one side. Okay, so I'm solving for x. This one does not have an x, this one has an x, this one has an x, this one has an x. So I need to get everything that has an x on one side. So we're going to put everything on the right, which means I'm going to add this one plus x in y minus xm minus xm. So that cancels and that cancels. So I end up with NA equals xnk plus xny minus xn, hold on, yeah, xn, xm. That's an m. It looks like an n from here, but that's an m. Okay, because we did a minus xm and a minus xm. All right, so I got all of my x's on one side. Just a little NA over here. That was the only one that did not have an x in it. So now we're going to, step 3, factor out the variable that I'm solving for. So I'm just going to say variable because I'm running out of room. Variable. There's an A right there. All right, so I'm solving for x, so I'm going to factor out x, divide this by x, and I get nk, divide this by x, and I get ny, divide this by x, and I get minus m. And there's the x that if I distribute it back, don't I get back there? And then on this side, I just have NA. Okay, so now I'm trying to solve for x. Can you see that x is right there, and I want to get rid of all of that so that my x will be by itself on one side. So I'm going to divide both sides by all of that, okay? So we're going to divide by nk plus ny minus m, and on the other side, we're going to divide by nk plus ny minus m. This is going to cancel, and I have x all by itself. So guess what? X is NA over NK plus NY minus M. That's my answer right there. X equals all of that. Okay, can you see that? NA divided by NK plus NY minus M. Now, if you look at your answer in your book, it's going to have exactly that. And then what is it going to say? NK plus NY minus M cannot equal 0. Okay, because it is your new denominator. This is what X is equal to. NA over NK plus NY minus M. So NK plus NY minus M had better not be 0. All right, so let's go over the steps before we do our practices. Step 1, multiply both sides by the least common denominator. So first you have to build the least common denominator, and then you have to multiply both sides, which should get rid of all your denominators. Now, step 2, once you have an equation that has no more rational expressions at all, it's now just an equation with no denominators, then you're going to get all of the x on one side. Now, I used x to specify the variable in question, the one that you're supposed to solve for. That could be an x, it could be a p, it could be a q or an m or just about anything. Whatever they tell you to solve for, you're going to get all of the terms that have that variable in it on one side. Then step 3, you're going to factor out that x or whatever variable you're solving for. And then step 4 is you're going to divide both sides by whatever needs to be divided by to leave the x all by itself, because you want to solve for something, you have to get it all by itself. And step 5 is, don't forget that the denominator, the new denominator, cannot be 0. So that's a step you need to put in there. The new denominator cannot be 0. So now we're going to come back with our first of 2 practice problems. We're going to see how you do on your own. Okay, here is your first practice problem. Copy it down. Then I want you to pause your video. Now, they did not even put the restrictions on here, but we know that M cannot be 0 and B cannot be 0. So that's what they did on all the problems, but on your practice, they didn't put them there. You'll see that they very often will end up dropping those after a while just because you're supposed to know that anyway, but I'm going to put them there because we're just learning this lesson. All right, so go do this problem and see if you can get it right without me, and then tune back in. Just pause it. All right, so hopefully you did that. Let's go through the steps. The first step is multiply both sides by the least common denominator. Now we're trying to find B. So I'm going to move this over a little bit. I'm going to put B as my trying to solve for B, and then I'm going to take this and I'm going to multiply by the least common denominator, which is MB. So MB over 1 is going to be multiplied all the way across that equation. So M is going to cancel M, leaving me with a 3ZB plus MB is going to cancel the B and leave me with an MN equals, now there's nothing to cancel over here, so it's just going to be MBF. Okay, so that's step 1, multiply through by the least common denominator. Step 2 is get everything that has a B in it on one side. So this one has a B and this one has a B. So I'm just going to subtract this one from both sides. So minus 3ZB and minus 3ZB. This cancels, and I'm going to have, that should not have a line under. That's not a division, that's a subtraction. And then this one goes out, and we have MN equals MBF minus 3ZB. Now step 3 is factor out the B. So MN equals B times MF minus B times minus 3Z. Okay, So step 4 is I'm trying to get the b by itself. So I'm going to divide out everything else that's with the b. So I'm going to divide mf minus 3z, divide on this side mf minus 3z. Okay, so now this is all going to cancel, and I have b by itself on one side. So I'm just going to, even though I'll do this, since this is all b, we'll just put b right here. B equals, because I don't want to have to write it again. And besides that, I'm running out of room. So since mf minus 3z is in the denominator, step 5 is to write mf minus 3z cannot be 0. And that is your answer to your first practice. How did you do? Did you get it right without having to look? All right, there you go. Right, so here is the last practice problem. And we're supposed to find m. And here is our equation. Write it down and go do your best to do it by yourself. Okay, so pause your video and go do your best to find m. All right, so here we go. Step 1 is to multiply through by the least common denominator, which would be ym. So we're going to multiply by ym over 1 all the way across this entire thing. So when we do that, the y's are going to cancel, and I'll be left with a 3am minus ym will cancel, the m's will cancel here. And oopsie, there's an s right here. I missed it. So this s just has a 1 on the bottom. So we're going to multiply it straight across. Minus sym. And then we go on to this one. This is a whole nother term. K over m cancels the m. So leaving the y times the k. Yk equals, x is also just over 1. So it's going to be ymx. And we're solving for m. So step 2 is to get all the m's on one side. Now I already have an m and an m. This is a yk and this has an m. Okay, so I'm going to have to do a little bit of juggling here. I'm going to go ahead and move this one over here and this one over here. So I'm going to say minus yk, and then I'm going to minus the ymx, minus ymx, and then over here, I'm just going to put minus ymx. Now I'm going to get it all cleaned up here. So I subtracted the yk, so it's gone. I subtracted the ymx, so that's gone. So now I have 3am minus ym minus ymx equals negative yk. Now I'm trying to find m, so now I have an m and an m and an m all together, and my minus yk is over here. Okay, so now, and I think, yes, that does look like an S instead of a 5, so I'm going to go with that. So now I'm going to step 3, factor out all of the m's, because that's my variable I'm solving for. So m, and I get 3a minus m sy minus m yx equals negative yk. So since I'm solving for m, don't I want to divide everything? 3a minus sy minus yx, divide this side by 3a minus sy minus yx. So this cancels out, and I get m equals all of this minus yk over 3a minus sy minus yx. What a mess. And then last step, so that was step 4. Step 5 is to write out all of this in the denominator. 3a minus sy minus yx. 3a minus sy minus yx does not equal 0. And I'm out of board, but I wanted to make sure I put it all down there. Wow. Aren't you glad we just have one section of abstract rational equations? I know you're tired because I'm tired too. But we're done. And this is Mrs. A, and may God bless your day.